And then we're just going to get started on 5.3 right now. And everything should work out here, I hope. Let me see. Here we go. And we're going to talk about rational equations and inequalities tonight. So that's why we kind of need to spend a little bit of time on this section right here, because there's this one right here, this 5.3. This is the one that's got a lot of information on it. So if you bear with me, I'll give you a break, and then we'll come back, regroup, and we'll do 5.4, which is definitely much easier, much more calculator based. You won't have to cry too much. All right, so solving some fractional equations when the variables are on the bottom, there's a couple things you need to remember. First things first is I like to find what's called the LCD, the lowest common denominator, and multiply it to everything. So, you know, the whole phrase, whatever you do to one side, you do to the other side. And that's what you do with a least common denominator. So in looking at this one right up here, first of all, you want to make sure everything is in a factored form because you weren't trying to find the lowest common denominator. This one would factor into 1 minus x, 1 plus x. But my common denominator needs to be, if you remember finding common denominator, it's the lowest common denominator that all the terms can go into. And so I wish that these were kind of switched around. Like I wish there was an x plus 1 and an x minus 1. Well, you can do that. Very simple. By taking out a negative on the top. So if I pulled out and made this a negative 7x, then this bottom would become positive x squared minus 1, which means that that factors into x plus 1 and x minus 1. Whoops. And you're going to have a question like this. That's why I want you to make sure you know how to do that. And why did I do that? Because notice now everything has, well, this right here has an x plus 1, x minus 1, and that's what I want to make everything. I want to make everything turn into that common denominator, okay, that they can all divide by or reduce to. So what I do is I multiply everything by it. So I take this and I multiply by x plus 1, x minus 1, and I like to write it in the top. And I do it to this one. And of course, I didn't leave myself enough room when I was typing this. And I do it to this side also, x plus 1, x minus 1. That's the common denominator. It's like if you had, like, just to give you an example, like 4 over 7 plus 8 over 5 equals, you know, you would multiply to figure out what that would combine to be. You'd multiply by the common denominator, which would be both of them, 35. So you multiply this by 35 and you multiply this by 35. That's really essentially what I'm doing. So what happens is the x plus 1 cancels with the x plus 1 there, and you're left with the 4 and the x minus 1. And then this x minus 1 cancels with this x minus 1, and you're left with the 8 and the x plus 1. And don't forget the minus that's in between. So minus 8 times x plus 1. And then this side, the x plus 1 cancel, the x minus 1 cancel, and you're just left with that negative 7x, which we had changed it to. And now this becomes an equation without fractions. So it's just so much nicer and easier to solve. So we just distribute and solve. So let's see if I can solve this real quick. Combine my like terms. Let me add the 4x over here, I guess. So negative 3x equals negative 12. And then divide by 3 would be 4. All right, now be careful right here because this is the step that many students forget. You solve, you get out a nice number, you did all your lowest common denominator, but there is something called extraneous roots, and you need to check for them. Check for extraneous roots. Now, what is an extraneous root? So an extraneous root is an extra root that occurs that when you solve it, it solves out nicely. You get like x equals 5 or whatever, x equals 4 in this case. Sometimes you get 2 answers, which you'll see in a minute. But you have to double check that that extraneous root works back into the original, meaning if you plug that in to the bottom, really, you just have to check the bottom. Will it give you a 0? Because if it gives you a 0 in a bottom, it's an extraneous root. It's an extra root that occurred that you don't want to use. And so that is something that you need to be careful with rational equations, really. So check for something called an extraneous root. This one works. This 4 right here would work fine. It would work fine here. I wouldn't cause a 0 in the bottom. So definitely want to check for something called extraneous roots. Let me actually show you. Let me kind of skip to an extraneous root that we will have. If you go over to the second page example, I should have put this on the next one, but this one right here, where it says x over x minus 2 plus 1 over x plus 2 equals 8 over x squared minus 4. So once again, I like to multiply everything by the common denominator, which is this one right here, because if I factor it, I get x minus 2, x plus 2. And that's what this fraction's bottom can become, an x minus 2, x plus 2. This can become an x minus 2 and x plus 2. So what I do is I multiply every piece of the fraction by that common denominator, x minus 2, x plus 2. This part, x minus 2, x plus 2. Even this part, x minus 2, x plus 2. And I cross off factors that don't belong anymore. So x minus 2 and x minus 2 cancel. But what am I left with on top? An x and an x plus 2. Plus x plus 2 cancels with x plus 2. And what am I left with here? 1 times x minus 2. What about on this side of the equal sign? Well, they all cross off except for the 8. And so now I solve this. So I distribute, I get x squared plus 2x plus x minus 2 equals 8. Now, how do I solve for an x squared? Well, you set everything over to one side and set it equal to 0. So let's see, x squared plus 3x minus 10. And then we factor it. We know how to solve quadratics. Two numbers that multiply to negative 10 but add to 3, we would be positive 5 and negative 2. So my answers for x are negative 5 and a positive 2. But this is what I was talking about before. Both of these do not work in the original. Which one is it? If you think about it. Negative 5, I really only check the bottom. Negative 5 minus 2, that works. You wouldn't get a 0 there. But if you plug 2 in right here, 2 minus 2 would make 0. This is called an extraneous root. It's an extra root that just doesn't work out correctly for my fractional equations. So the only solution to this one is negative 5. So that was an example really of what an extraneous root is. And you'll have one of those on homework tonight. Let's go back to the front page. Let me show you some other examples that they're going to give you of fractional equations. And I know it's very hard if you don't remember what your lowest common denominator is. It's really what, really it's like the highest degree, or it's like each factor on the bottom. Again, think of like, if you had 4/7 and 8/5, you would just do 7 times 5. That would be your lowest common denominator, which is 35. So here you could just do x times x squared and call it x cubed. You'll get an answer at the end that you'll have to like reduce. But to be honest with you, you could make all of these into x squared. They all could become an x squared. So again, I multiply everything. I multiply the 1 by x squared. I multiply the 5 over x by x squared. I multiply the 9 over x squared by x squared. And then if it crosses off and reduce. So let's see, 1 times x squared, well, that's x squared. X can go into x squared, it can divide, and you're left with an x. And 5 times x is what's left on top. Equals x squared and x squared cancel, so you're just left with 9. Now that's pretty easy. Set it equal to 0. And see if you can factor it. Well, unfortunately, you can't. One of them on the homework tonight, you're not going to be able to either. You have to do quadratic formula. You could, again, you know the tricks now. You could put this in Desmos and find out where the decimals are. But you know Pearson, it likes it written in radical form. So let's just refresh ourselves on how to do quadratic formula. So negative b, so -5 plus or minus square root of b squared, which is 25, minus 4 times the 1 times the -9, all over 2 times 1, 2a. So this is 25 plus 36. 25 and 36 is, I think, 61. Yes, I think it's 61. So -5 plus or minus the square root of 61 over 2. And 61 isn't reducible. So your two answers would be -5 plus the square root of 61 over 2. And that's how you have to write it in Pearson. And -5 minus the square root of 61 over 2. And that's what you'll have a question like too. Let's move on to this one. So this one is actually just like this one. It's just written a little bit differently. It's written with like exponents that are negative, but that's okay. We know what a negative exponent means. If you're a negative exponent in the numerator, it really means you should be written in the denominator as positive 4. Same thing here. 35x to the -2 is really 35 over x to the positive 2. And then you have -4. So now all these fractions, what can all the denominators become? What can they all become? They can all become an x to the 4th. I can make an x squared x to the 4th. I can even make this x to the 4th. So that's the common denominator that I'm going to multiply everything by. I'm going to multiply this by x to the 4th. This one, you have to do this 4. You even have to do the 0, but we know it's going to become 0, but we'll still do it anyway. And then what ends up happening is this x to the 4th and this one cancels. You get 9. On this term, x squared cancels into x to the 4th, and you're left with an x squared. So you have minus 35x squared. And then you have minus 4x to the 4th, and then this still stays 0. Now, I don't like the way this is written. I like my polynomials in descending order, like the highest degree first, plus this one is a negative high degree. So I'm actually going to, like, what I'm doing right now is I'm just going to move everything over to this side. I'm going to add this term over, and subtract. So really I have positive 4x to the 4th, positive 35x squared, and then a minus 9. So I literally took all this equation on the left and I just moved it to the right. And now I'm going to solve this. And so this is actually a trinomial that we can factor, which we've learned before. This is in a trinomial quadratic pattern. So what multiplies to 4 times -9, which is -36, and adds to 35? So let's see. Instead of putting x here and x here, if it's x to the 4th, I'm going to put x squared. Because x squared times x squared is x to the 4th. Two numbers that multiply to -36 but add to 35 would be positive 36 and a -1. However, because there's a 4 in front, I'm going to divide both of them by 4. And let's see if this will reduce to x squared plus 9. This one you have to do what's called, you bottom it up. You bring that 4 in front of the x squared. And then you set each one equal to 0. So x squared plus 9 equals 0. And 4x squared minus 1 equals 0. So let's see, this would be x squared equals -9, take a square root, and you know you're going to get an I. So this would be x equals plus or minus 3i, the I from the negative, and then the square root of 9 is 3. So there's 2 of your answers. This one, well, truly, this could have been factored further. You can actually factor this into 2x minus 1 and 2x plus 1. And then set each one of those equal to 0. But you can still leave it the way you're doing right now. You can add 1, divide by 4, and then take a square root. But you end up getting a positive 1/2 and a negative 1/2. So there are all your answers. And again, you just want to double check that none of them would cause a 0 in the bottom. If you plugged in 1/2, you want to get a 0. 3i, you want to get a 0. So that those are your answers for extraneous and for rational equations. I'm saying extraneous. Okay, so really the biggest thing is going to be this idea of multiplying by a common denominator. It really will help save you time if you can do the lowest common denominator. All right, now for the big thing that I saw on the homework for tonight. They're going to give you a graph of a rational function, which we just learned from the last class, these little hooks here. And we know that there's asymptotes located inside of them. We've heard all about that. But they're going to ask you 3 questions specifically. And I'm just going to let you know they're going to continue to ask these 3 questions in the next further chapters. In the end of chapter 5, 6, on the test, etc. So let me try to give you some hints as to what these mean. So if they ask you, what is the solution to f of x equals 0, and they give you a picture, here's really what they're asking. F of x equals 0 is really the y equals 0 line, or the x-axis. They're just asking you, hey, where does it intercept the x? What's the x-intercepts? Well, if this is the hook graph here and the hook graph here, we learned last time that there is an asymptote, a horizontal asymptote at 0, and then there's a vertical asymptote, which looks like it's at 5. Right here. And then there's a horizontal asymptote at 0. So what does that mean? Asymptotes, again, are lines that the graph will not touch, will not cross over. So this is not going to intercept the x-axis. So the answer to this is no solution. It will not intersect that at y equals 0. It's just not going to ever intercept the x-axis. This question is saying, okay, well, what is the solution then to f of x less than 0? Or what are the x values that make the y less than 0? Pretty much, which part of the graph is underneath this line right here, underneath this axis right here? Because that's really what they're focusing on. Which part of the graph is underneath that line right there, is less than? And that's this hook right here. And so you have to write it in interval notation. And you would say, okay, well, it would be on the x-axis, it would be from -infinity up to that asymptote. So from -infinity up to 5. That's the solution for all the y values that are less than 0. Well, and then opposite way of thinking. What's the solution to f of x greater than 0? Where's the picture greater than that, than this axis right here? And that's this hook right there. Those are all the solutions to the graph that are greater than 0. And again, you just write it in interval notation, which would be from 5 to infinity. So when you see it like this, it means where is it intercepting the x-axis? when you see it like this, it's asking you, okay, where is it below the x-axis? And when you see it written with greater than, it's where is the picture above the x-axis. So we'll do another one, just so you can understand and see the way they ask it is always different. All right, so what is the solution to f of x equals 0? So again, this is the line they're worried about right here. Even though they gave you in the picture another horizontal line, this is still the line that they're concerning themselves with, okay? So again, where is the x-intercept happening in this picture? Well, like I kind of made it a little dark for you, but it's right there. That's where it intersects the x-axis. And that is at, I think it's -3. Yes, -4, -3. So -3 is where it's intercepting the x-axis. What's this one saying? Well, this one is saying, okay, think of that yellow highlighter line right there. Where is the picture below, less than that yellow highlighter line? Well, that would just be this portion right here. That portion would be below the yellow highlighter line. Well, how do I write that in interval notation? Well, this was at -3 up to where? Up to where on the x? Up to 0. Now this one is even crazier. This one's saying, okay, well, where am I above? Where's my picture above that yellow highlighter line? Well, definitely this one's above that portion right there. But look, there's another portion of the graph that is above the yellow highlighter line. You have to write both of them. So let's see, what would that be? And again, we're talking about x values. So the x values would be from -infinity up to -3. And then the next portion above the yellow line would be, again, where on the x? Where on the x is this? So from 0 to infinity. So two very tricky pictures that I saw they had on homework tonight. These are the x answers. You have to write them in x interval notation. And you're looking at where are they above the x-axis. And you write the x answers for that. Hopefully that made more sense, because when you see it on homework for, I think it's homework 15, you definitely want to be careful about those. All right, moving on, we're doing excellent. They're going to give you a question on Pearson like this, where they say, okay, you know, they love to do that. They give you 2 over x plus 3 equals 13 over x plus 3. When is 2 over x plus 3 greater than 13 over? And when is it less than? Okay. Same idea of what we just did before. But let me kind of make this easier for you when you get a question like this. The best thing to do is like set this equal to 0. And make it so that you can look at the graph and look at the x-axis like we were just doing before. So here's what I mean. I'm going to take this, I like to move everything on the left, so I'm going to have 2 over x plus 3 minus 13 over x plus 3 and set it equal to 0. Well, if you know your fraction rules, which you should, you're in pre-calculus, so when you have a common denominator, you have 2 fractions, you can keep that denominator and then combine the top. 2 minus 13 is -11. And now that's what I'm going to do for all of these. Instead of looking at 2 over x plus 3 greater than 13, whatever, I'm going to write -11 over x plus 3 greater than 0. On this one, I'm going to look at -11 over x plus 3 less than 0. And I'm going to put this on Desmos. I'm going to put this function right here, -11 over x plus 3, on Desmos. Negative 11 over x plus 3. And again, what am I looking for if it says negative 11 over x plus 3 equals 0? Well, I'm looking to see, I'll even type it in, y equals 0. I'm looking to see, I was going to change it to yellow, or maybe I'll change it to orange. And then I want this to be, I'll make this green or something like that. Let's make it purple. There we go. Okay, so I'm looking to see this orange line. Where would the purple, if it says equals, where would the purple intersect? Well, once again, that's an asymptote. It's not going to intersect the asymptote. So that right there is already my answer. Up here, it would be no solution for that one. And again, if you want to graph this, you give yourself a little graph here, which I might do right now. You're all the way at -3. And then negative 11 would go. I think the hook was here. Here. And all we have to do is look at that x-axis right there. So where is it intersecting? That's what equals means. Where is it ever going to cross? It doesn't. Okay. What about for this one? Where's the picture greater than 0? Where's it greater than? Where's the hook above the yellow line? And it's above the yellow line right here, which we would say from where? From negative infinity up to, where is that asymptote? From negative infinity up till -3. So this has no solution. This one has a picture above the yellow line up to the asymptote. What about this one? Well, this would be below. So where's it below that yellow line? It's right here from the asymptote to infinity, from -3 to infinity. So I think it's easier to do that problem this way. Set them equal to 0, then greater than 0, then less than 0, and look at the graph. That's much, much easier. All right. Now, for our favorite things, inequalities with rational expressions, which is what we were doing before. But, oh, my dog's growling a little bit at other dogs now. So when you are dealing with inequalities and rational expressions, you have to do what's called a sign test, okay? And you could use this in Desmos, and you could look at all these in Desmos just like we were doing before, and that's fine with me, but I do want to show you how to do a sign test, just so you understand. I think we've done it before. We've done it definitely with quadratics, but I want to show you how to do it with a rational expression. Sorry, blinked out for a second. Okay. So if I had 3 minus 2x over 6 plus x is less than 0, what you're supposed to do is you need to, and I'll write you a little bit of notes here. You have to do what's called plot the zeros and where it's undefined. Now, what does that mean? Well, the zeros are located on the top. So it's where the function would be 0 on the top, because you're allowed to be 0 on the top. So 3 minus 2x equals 0. So what does that give me? 3/2. The undefined part is what's on the bottom. Where would it be 0 on the bottom, which is where it's undefined? So 6 plus x equals 0, -6. So you're going to do on number line, we've done this before, and you're going to plot those 2 points. You're going to plot -6, and you're going to plot 3/2, which is about 1.5. And then you're going to do a sign test. And remember, there are 3 different zones that you've now constructed. And you're going to do a sign test on them. So do a sign test and test each zone. So what do I mean by sign test? Again, we've done this before, so hopefully you have done it. But you pick a value in this zone. And, I like to pick x to be -10. And you plug it in to your function, and you really just look at the sign. Here's what I mean. If I plug -10 into the top for x, this would become positive on top. If I plug -10, though, into the bottom, 6 and -10 would be a negative. And if you know your rules for signs, which you should, any positive number divided by any negative number is negative. Let's do that again. Let's do the middle one. So pick a number that's in between -6 and 3/2. So that would be like 0. So if I plug 0 into the top, I would get what sign? Well, I would get a positive number. If I plug 0 into the bottom, I would still get a positive number, which means that's positive. One more section. Let's do 10. If I pick 10 and I put it in top, I would get a negative. If I pick 10 on the bottom, I would get a positive. Negative divided by a positive is negative. Now, you shade what's true. Shade what's true. What does that mean? Well, we're looking for the values that are less than 0. If you're less than 0, you would be negative. So it would be this section here and this section here. And because this doesn't have an equal to sign, everything has a parenthesis. So your solution would be from -infinity to -6, united with 3/2 to infinity. And that's how you could do a sign test on these inequalities. Again, you could plug them into the calculator and look to see the answers that are, or into Desmos. And actually, let's do it right now while we're here and see what it looks like. I'm going to keep y equals 0. Let's see. 3 minus 2x divided by 6 plus x. There we go. So, I mean, if you're very good at reading these, which a lot of you are very good, again, here's my orange line. That's the x-axis. And I'm looking for, go back to the original problem, the answer, the parts of the graph that are less than 0, less than 0. Well, that would be from -infinity up until this right here, this asymptote, which is -6. Okay, that is -6 right there. And then the next portion that's below it is right here at 1.5 or 3/2. So that would be 3/2 to positive infinity. And that's what we got. We ended up getting the same thing. This is just a visual way of doing it. This right here is the algebraic way of doing it. So I want to show you both ways because I know I'm more of an algebra person, as you can see, but I know there's people here like, I can put this in Desmos and read it right quickly off the graph. Then that's fantastic. That's what I want you to do then. Let's do this one. 1 over x minus 2 is less than or equal to 6 over x minus 2. Again, I would get that equal to 0. So I'm going to subtract that 6 over x minus 2. And what does this become? Well, they have the same denominator, so it becomes -5 over x minus 2. And again, just to show you, I'm going to do this a sign test way, and then I'm going to show you how to do it on Desmos because some of you like it both ways. So the sign test way would be whatever makes 0 on the bottom and the top. Nothing makes 0 on the top because it's already a -5, but 2 makes 0 on the bottom. And so I'm going to pick a number that comes before 2 and a number that comes after 2. So if I pick x to be 0, the top would be negative because it's -5. The bottom would be also negative, which means that's a positive. On this right side of 2, I'm going to pick 10. The top would be negative, and the bottom would be positive, which is a negative. And now let's answer the question. Less than or equal to 0. Which ones are less than or equal to 0? Well, that's this side right here. Now here's the trick. If this 0 that you picked is the number in the bottom, you are never allowed to have a bracket. You must have a parenthesis in the bottom. Parentheses are in the bottom. But brackets are if they were on the top. You can actually be a bracket. So this answer right here, even though there's an equal sign, this answer is 2 to infinity. 2 to infinity. And again, plug this into Desmos. -5 over x minus 2. And let's see it visually. -5 over x minus 2. And again, I'm looking, here's the orange line. I'm looking for where is it less than? Where's the picture less than? Where's the hook below the orange line? Well, that's from this asymptote right here, which is -2, which is where the bottom is, all the way to infinity, okay? Which is 2, excuse me, not -2. And so that's why it's good to see both sides, the algebra and the geometry. All right, I think one more of these, and then we get to do some application problems. Woohoo! So here is x minus 3 times x plus 6 over x minus 8. And again, I'm going to do the sign test part of it, and I'm going to do Desmos for you. So you need to, again, plot all the zeros and where it's undefined, which is on the bottom. The zeros are what makes it 0 on top. So 3 would make a 0 on top because 3 minus 3 is 0. -6 would make a 0 on top. On the bottom, it would be undefined at 8. So we're going to plot those. So -6, 3 would come next, and 8. So we got a couple of zones here. 1, 2, 3, 4 zones. And so now I'm going to do my test. Okay, so I'm going to pick points. So let's pick x to be -10. You're going to plug it into this factor, and this factor, and you're just going to look at the signs. Watch what I do. If I put -10 in for x, that factor would still be negative. If I put -10 in for x here, it would still be negative. If I put -x in the bottom, it would still be negative. 3 negatives stay negative. It's only 2 negatives that ever make a positive. Let's pick another one in this zone. Let's pick x to be 0. So if I plug 0 into x into that factor, I would get a negative. If I plug 0 here, positive. 0 down here, negative. 2 negatives, whether you're multiplying or dividing, become positive. Pick, I don't know, 4. Pick 5, but so let's see. I would have a positive, but a negative on the bottom. 1 negative, still negative. And then again, you can pick 10, you'll see they all become positive here. And now answer the question, what values are less than 0? That would be here. And that would be here. So I would say my solution would be from -infinity to -6, united with 3 to 8. That would be the section. And you can look at this at Desmos. It just gets a little complicated because you're just kind of wondering where the asymptotes are. But again, if you're like that visual learner, this would be up your alley too. You can look at Desmos, but this is just another algebraic way of doing it. All right, just to end this, and then we'll take a break. Just some applications to rational equations, and one of them being direct, inverse, and joint variation. Now, you probably haven't heard these since a long time. Like I was just doing it with my calculus students. They hadn't seen it since they were in Algebra 2. So let me give you the formulas for these. Direct variation is when you have like two unknowns that you're multiplying by some constant k. So it's really a multiplication of k when you see the word direct. When you see the word inverse, it's the division with k. And then when you see the word joint variation, it usually is multiplying k by like a couple of things, like an x and a z. But it's this idea of k right here. That's the guy you have to solve for first. So you first want to solve for k. And then you solve for the like whatever other missing variable after that. Okay, but that's the main thing, to solve for k first. So these aren't that bad. They're usually pretty easy. They look harder than they are, but let me show you what I mean, and then we'll do a couple of examples and it should be all right. Suppose t varies directly as the square of m and inversely as x. If t equals 19 when m equals 12 and x equals 9, find t when m equals 36 and x is, I mean, it just sounds like what the heck? I don't even know. Don't get overwhelmed. All you have to do is remember this little guy k, okay? And if it says direct, you multiply by k. If it says inverse, make sure you're dividing by it. So let's go back here. Suppose t, so we're not using y or x's, we're using t. So suppose t varies directly. That means multiply a k by what? Well, let's see. It tells us multiply a k by the square of m squared. But also do it inversely. Well, what does that mean? That means divide that k. So we're not going to put another k here. We're just going to go divide by whatever variable they have. Because putting another k here, it just is redundant. We're trying to solve for that one constant variable. So here is your formula. You've built a new formula that you're going to solve for k. Suppose t, here's t, varies directly. That means multiply by a k with the square of m squared. Inversely just really means divide that k by whatever they give next, x. So here's your formula. Box it. Now we're going to solve for k with what they give us first. They tell us t is 19, okay? Put 19 right there. When m is 12, well, k is what I don't know, but m is 12, so I know that, 12 squared, and x is 9. Don't even go further. Just stop right there, and we're going to solve real quick. We're going to solve for k. So 12 squared is 144. Well, actually, let me do 19 times 9. So that's 171 equals k times 144. I'm going to divide by 144. All right, so K looks terrible. 171 divided by 144. That's okay. Keep that there. Solve for K. You just did it. Now, you are going to literally take this formula that you had just written, and you're going to replace the K into that formula and write a new formula. So watch. T equals 171 over 144 times m squared over x. So all I did was I started with my formula, I solved for K, and I wrote it again with my K substituted in. So here's my new formula. And now I'm going to answer this second part, whatever the last part is, I'm going to answer it now. Find T when m equals 36 and x is 9. Okay. So find T, here's T. M is 36. I know what K is. K is 171 over 144. M is 36 squared, and X is 9. And you're going to do, please excuse my dear Aunt Sally, so make sure you do the 36 squared first. Is 1296. And then I'm going to multiply that by 171 over 144. And then I'm going to divide that by 9. And I get a little, ugly fraction here, but that can be made into a fraction. Just hit math frac. 19 over 144. That's not right, according to what I have here. What did I do wrong? Let's see. 36 squared. Did I hit something wrong? 1296 times 171. Divide that by 144. Divide that by 9. I did hit it wrong. There we go. See, even I didn't do my order of operations correctly. Sorry for the glare. Sorry about that. 36 squared, my bad, was 1296. And I'm going to multiply it by 171. Then I'm going to divide that by 144. And that's what I did wrong. So this became, 1539 divided by 9, which is 171. So there's my answer. Something very complicated for very formula-driven kind of thing. Let's do another one of those though, so it makes more sense. If A varies directly, when you see that word varies directly, just think times by K, multiply K, times by K. Okay, so if A varies directly, so times by K. What am I going to times by K? I'm going to times the next little sentence, M and N squared. Okay, so N squared. Inversely means divide that K. So I already have a K, just divide by it. What am I going to divide by? Y cubed. So there's my formula. And I'm going to find K with the first piece of information they usually give you. So let's see what's the first piece of information they give us. A is 4, M is 9, N is 4, Y is 2. Okay, let's find K. Plug all those in. A is 4, K I don't know, M is 9, N is 4 squared, and Y is 2, so 2 cubed. And you do a little bit of math magic here, 9 times 16, and then that's 8. So 4 equals, what's 9 times 16? Why can I not think today? 144, oh yeah. Divide by 8. 8 times 4 is 32, so 32 over 144, which is reducible. 32 divided by 144, 2/9. Okay, so now that you solve for K, look what I just did above there. Rewrite this top equation with that K substituted in. So 2/9 mn squared over y cubed. That is now your new formula, and you're going to solve for the second half. So it's kind of like two problems in one. And the second half says, okay, find A when m is 6, n is 3, and y is 7. So you just literally put those in, 2/9, m is 6, n is 3, so 3 squared would be 9, over 7 cubed. So let's see, those cancel. And you're left with 12 over 7 cubed. I think it's 343. Let's see if I'm right. I am. And there's your A value. And yes, you will get ugly fractions just like this one. So make sure you know how to do it. Okay. Last two. I told you this was the hardest section, and then I will give you a break. I promise. If you could just bear with me, we're almost done. This one for sure, put a star next to it. Memorize it. I have seen it on the next chapter test. I have seen it on the final exam. So if you can do this one, and I've seen it on the review basic quiz. So this one, for whatever reason, is on them all. So know how to do this one. Sally can paint a room in 7 hours while it takes Steve 3 hours to paint that same room. How long if they work together? So I like to make a table for this. This is how I've always taught it when I taught this in Algebra 1. You've got Sally and you got Steve. And you do what's called a Sally and Steve's work rate. And you're going to multiply that by the time that they're painting or whatever. And it equals a job. So this is the little chart that I always do. This is called a work rate problem. Okay. So let's talk about this. If Sally can paint a room in 7 hours, then her work rate for 1 hour, you would call it, she could get 1/7 of the job done. That's her work rate. If it takes her 7 hours to do a whole room, she'd get 1/7 of the job done. Steve can do it in 3 hours, so then his work rate is 1/3. Okay. Well, if they join forces and they decide to paint the room together, we're going to find out, well, how long it would take. So that time-wise would be, they would be doing the same amount of time because they're joining together to paint the room. So we're going to call this X and X. And we're going to multiply across. So 1/7 times X would be 1/7 X, or X over 7. 1/3 times X is X over 3. And then this is the little phrase I remember, and I say to my students, I say, to get the job done, set it equal to 1. To get the job done, set it equal to 1. So you're going to take this last column right here, and you're going to set it equal to 1. So X over 7, Sally's rate, plus X over 3, Steve's rate, set it equal to 1. And just like we were doing in the beginning, you're going to multiply everything by the common denominator. This is how I would do it, which would be 7 times 3, which is 21. And 7 goes into 21 3 times, so this would be 3x. 3 goes into 21 7 times, so this would be 7x, and this would be 21. And that makes 10x. And x is 21/10 for 2 1/10 of an hour. It will take them 2.1 hours to finish that room. So an easy problem to do, and definitely one that you're going to see multiple times. All right. Looking at this next problem, though, this one's going to take us a little bit of time. So I'm going to take a pause right now because I want us to kind of be fresh. You do have one of the problems like this on the homework. I don't think it's on a quiz or anything. But let's pause. Let's take a 10-minute break. We'll come back. We'll do this problem, and then we'll do the second half lesson, which is the 5.4, which is again much easier. It's more, I promise you, you could do it